All right. So the question says, this is actually a very fairly simple, like fairly standard backtracking question that's there in backtracking. So let's have a look at it. Generating permutation has always been an important problem in computer science. Okay, somebody's saying, somebody's still stuck on the previous one. So I'll just come. Somebody's saying 12 modulo 13 is 12, not 1. I am 100% with you, boss. I never said 12 modulo 13 is 12. I am saying, and you can look this up later on because this is not a Java versus Python class. The confusion is this: 12 modulo 13 is equal to 12. Nobody denied that. 100% agreed with you. Minus 12 modulo 13 is what? Is it minus 12? Is it 1? Right? So Python will give you 1. Java will give you minus 12. This is the confusion. This is all I'm saying. In our case, minus 12 does not make sense. Why does it not make sense? You cannot have negative chairs. In the question, the chair number has to be positive number. I cannot take negative number. Hence, Java's negative is wrong. Python's positive is correct. But mathematically, which is correct? Mathematically, we prefer this one, but mathematically, this one is not ruled out. Minus 12 is not ruled out. Okay. So that is where the confusion is. Please go ahead. Really, all Java students, check out your language's modulo behavior. It is not the ideal modulo behavior. So do check that out. I'm saying that as someone who also uses Java. Okay. So I also use Java a lot, but we have faced this a lot with Java students. So please check that out. The modulo behavior is not ideal. Anytime your number is going into negatives, anytime your number is going into certain negatives, don't do modulo of that. Make sure you're doing modulo only of positive numbers in Java. Okay. Using math.abs. My friend, if you use math.abs over here, it will give you 12, right? It's going to start giving you 12 is minus 12 modulo 13, which is wrong. Minus 12 modulo 13 is not 12. Please don't misunderstand that. Minus 12 modulo 13 is not 12. Somebody is saying minus of 12 modulo 13. Minus of 12 modulo 13. Can anybody point out what's the mistake in this one? Minus of 12 modulo 13. Can anybody point out what's the issue with this one? It's still going to give me a negative value. It's still going to give me a negative value. I want to avoid a negative modulo, right? You understand the issue? It's still, and remainder cannot be negative. Actually, very good. Thank you. So this is why this is also wrong. Modular arithmetic is not the same as your usual arithmetic. By what logic is it giving us 1? Okay, if you guys really want to go down that, let me just quickly show you. What are the values modulo 3 you can get? I'll show you the smaller example. What are the values modulo 3? Can anybody quickly tell me modulo 3? What are the values? 0, 1, 2. That's it, right? So let's say I take all the numbers. Okay. Let's say I take all the numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you tell me all the modulos of this? It's going to be 0, 1, 2, 0, 1, 2, 0, like 0, 1, 2, 0. It's going to keep repeating. The negative numbers, if I go back minus 1, what should it be? As per this pattern, what should minus 1 modulo 3 be? If it's going to continue this pattern, 2. Very good. What should minus 2 modulo 3 be? 1. What should minus 3 modulo 3 be? This we all know should be 0. Okay. Whenever you're confused with negative numbers and modulo, always keep this table in mind. So all my friends who are saying minus 1 modulo 3, sir, just do absolute value. Absolute value will give you 1 modulo 3. But is minus 1 modulo 3 1? Is it 1? No, right? So now you understand. Basically, at your level, all I want to say is avoid negative numbers taking modulo. Do not take modulo of a negative number. Full stop. Make sure that the number is in a positive or 0 and then only take the modulo of it. Any intermediate steps that get you to a negative number and you're taking modulo, avoid that at all costs. Especially if you're a Java student. Python, you're still safe because your modulo is still good. If you're a Java student, please avoid it. Okay, cool. Awesome. All right. Are we all on the same page? Can we move on to this permutations 2 question, everybody, really quickly? All right. Shall we go? On to this question. Okay. I think you are muted. I am not muted. I think something might be issue at your system. If you all can hear me, please say can hear you clearly. Can you just say hearing you clearly or can hear you clearly? The person on the chat will get yes. Just say it on not personally. Just put it there. Okay. Thanks. Thanks, Rohit. Others, please also just put that on the chat like how Rohit has. Okay. Awesome. All right. Super. All right. Generating permutations has always been an important problem in computer science. In this problem, you will have to generate the permutation of a given string in lexicographical order. Interesting. What is lexicographical order? It's just alphabetical order. Okay. So what you need to do is, given a particular string, given all the strings, you need to generate, and you have to take input and you have to generate all of the permutations of that string. So for example, this is a fairly standard one, but you can expect this in TCS digital. You get AB. What are all the permutations? You have AB and BA, and they are in the lexicographic or alphabetical order. Okay. And if you do ABC, what will it be? How many permutations will you have, everybody? First of all, how many will you have? Then we'll look at how to generate, but how many will you have? Very good. 3 factorial is what you can have, right? N factorial, 3 factorial. So you'll have 6 over here. So starting with A, you'll have A, B, C, and you'll have A, C, B. Starting with B, you're going to have B, A, C, and B, C, A. And starting with C, you're going to have C, A, B, and C, B, A. Okay, everyone? Doing for 4 will be difficult because there will be 24. It grows exponentially. So n factorial, if I had A, B, C, D, you're going to have to generate 24 such elements, right? 24 such ones, and they have to be in lexicographical order, alphabetical order. Okay. Cool. So how do we actually go about doing this? Any thoughts and ideas, everybody? How do we do this? I just want some suggestions. Some of you might have an answer to this. So how do I generate this one? It's a backtracking question. So I'll tell you the backtracking approach. But otherwise, anybody who tried it wants to share some approach, some idea, you can share that. Any particular approach that you can think of? Because that's the question. You get a string and you try to generate all the permutations of it. Anybody, any thoughts, any approaches? Please let me know in the chat. Using recursion, yes, you have to use recursion here, but what's recursion? Like, or that's not what's recursion, but how would you use recursion over here? Yes, you have to use recursion, but how would you use recursion here? Sir, what if combination is asked in question? What do you mean by combination? What would you mean by combination? Sir, issue is sometimes voice can't be audible. If we reload page, it is audible. Just go to YouTube. There the voice is coming properly. So just go to YouTube. You can just follow it on YouTube over there also. I'm checking the chat there also. Don't worry. So YouTube, the voice is very nice. Just search YouTube Edyst. You'll get it. Okay. We have to swap indexes. Yes, you have to swap indexes. Sir, where can we find this question in Edyst platform? It's in your previously asked questions, the company specific preparation, and over the TCS digital, you'll find this. If you don't, just mail us, we'll add it. Okay. So everybody, this is a typical, like, how do you even know, first of all, that this is backtracking? I told you it's backtracking, but how do you even know? Whenever you have generate all combinations, right? generate all combinations, you know that it's a backtracking question. This is a backtracking question. Whenever you have a generate all combinations, 99% of the time it's a backtracking question. Okay. Cool. How do I generate it? Okay. Let's think of it this way. Let's think of it this way. In backtracking, now those of you who didn't attend the class on backtracking, this will be slightly difficult for you. But the way you work in backtracking is you find a recurring solution. That is, you find a pattern that is continuously recurring, right? So what is the kind of pattern that's recurring here? The pattern that's recurring here is, I'm saying, let's say I pick up A, B, C. I'm saying first you hold A, then generate whatever you can with BC. Okay, with B and C, generate all the generate all the combinations. Then you hold B, and with AC you generate all the combinations. And finally you hold C, and with AB you generate all the combinations. So I am taking turns in holding the first element, right? Which element will come first? I'm taking turns in holding that. Okay. All right. Can I further extrapolate this? Yes. Even when I'm generating with BC, how do I generate with BC? What do? I first hold B and generate all the subsequences with C, and you only have C, right? And again, you generate C and you hold all the ones that you can with B. And again, you only have B over there. So it just stops there. Same thing here. When you held B, now you're holding A and you try to do everything there, and then you hold C. What does this mean? Let's take a slightly bigger string, a longer string. So you'll get the hang of this one. Let me just reduce the font a bit. Okay. All right. So let's say, for example, I took A, B, C, D. Okay. Assume that the string is sorted. If it's not, we'll sort it first and then we'll start this. But assume that the string is like already sorted here. What am I going to do? I'm going to say, okay, take A and generate all the substrings of B, C, and D. Take B and generate all the substrings of A, C, and D. Take C, generate all the substrings of A, B, and D. And take D and generate all the substrings of A, B, and C. Yes, there will be 24. You are right. But how am I generating them? I'm always holding the first element and saying generate for the remaining. If I want to generate for B, C, D, this is again the same thing I'm doing here, right? I'm saying, you know what? First, hold B and generate for C and D. Then hold C over here. Then you hold C over here. Okay. And generate for, what do you generate for? B and D. And finally, you hold D and generate for B and C. Right? So at every point, what am I doing? I'm taking turns on putting the element first, right? It's going to be the first element, and then I generate for the remaining 2, or remaining 3, or remaining 4, or remaining 5. So even at the first I did this, I'm taking for A, I'm taking turns, B, I'm taking turns, C, I'm taking turns, D, I'm taking turns. When I come to B, C, D, again, I pick up B and try to generate for C and D. I take up C, try to generate for B and D. Take up D and try to generate for B and C. And for C and D also, I'll take C, try to generate for D. Then I'll take D and try to generate for C. Okay. Is this understandable, everybody? Are you guys getting how this is working out? The general way that I'm going to do it. Okay. Now, even if you've understood this, the next challenge comes, how do I write the recursive function? I get that this is the logic, but how do I actually write the recursive function? So whenever you're writing the recursive function, always remember that you should always start, at least it helps me, to always start at the recursive case. Don't start at the base case. Don't start by writing the base case. Base case is always difficult to write. Okay. Start at the recursive case, meaning that assume, let's say I'm saying generate, right? I'm on the generate thing. There are some things in the parameters. Okay. What is there in the parameters? Well, I have my candidates right now. The current candidates, my current string, or I can put it this way. I can say my current string. Okay. This is my current string at this point. Right. So this is basically my current string. And what I want to do with this current string is I want to give turns for the first letter. Again, I'm talking about the recursive case. I'm not talking about the base case. What do I do at any point? Let's say I'm saying generate for BCD. Okay. I'm not even talking about the first case. I'm talking always start somewhere in the middle. Let's say I'm at ACD. What am I going to do for ACD? I'm going to give every character the chance to be the first character. Okay. What does that mean? I'm going to go through the string. So, for let's say, char in current string, I'm going to go through. This is again pseudocode, everybody. So just follow the pseudocode. I'm going to go through each character and I'm going to say, you know what? Prefix is equal to my character. This one will become my prefix. Okay. And then what will I do? I'll say now let's say remaining is equal to current string pop, let's say character. When I pop, I'm just saying that remove that character from it. Meaning I take up, let's say for ACD, I give A the chance first of all. Okay. Let's say I'm giving A the chance to be the character. Okay. Okay. Better way to say it is not current string dot pop, but I'll just say remaining is, let's say without current string without character. Again, it's pseudocode. So syntactically it's not correct. But yeah. So I'm saying let's give A the chance and the remaining becomes C and D. Then in the next time, I'm going to give C a chance and I will ask to generate for A and D, right? And so on. So I'll say, you know what, prefix is this character. Remaining is, you remove that character from that. And what will you do? You will generate, you're going to generate all of the substrings from the remaining. So this is the recursion. I'm saying, okay, now again, go and generate for this remaining. And for each element in that remaining, you will say for each element in the remaining, you will say prefix plus element. So in the remaining, you got, what would you get? You will get CD and DC. So I want AC, I want ACD and ADC. Whatever is the remaining, you generated the entire thing, right? So I say generate, you generate all the subsequences of the remaining. Let's say this is, let's say not just say for each element in remaining, but I'll say, let me say, call this as next. So next is equal to generate the remaining part. So for each element in next or for each string in next, prefix plus element. So for example, from CD, I'm going to get CD and DC. So A will combine with both and make it ACD and ADC. Okay. Then when C is the first one, C will combine with both AD and C will combine with DA. C will combine with AD and C will combine with DA. So I get CAD and CDA. So like this, I am going to get for each element in next, prefix plus element, right, is what I'm going to get, right? And this will be, I would say, current answers, current answer dot append. So this will be another list of elements that I'm generating. And for this generate, for this set of generate, hold on. Just font size is too big. Yeah. So for this set of generate, I am going to return, finally, return the current answer. What is the current answer? The current answer now has to be a list. Okay. So current answer is equal to a list. It has to be a list. What is this? What happens in this list? I'll again repeat. I will take the first element. I'll give each element a chance to be the first one. I'll call it the prefix. I'll go through, I'll say the remaining string over here is without the first element. So it's like CD. I removed B. So it's only CD right now. I'll say go ahead, generate the remaining ones. So again, it's going to go into a recursive solution. Okay. Whatever gets generated from that, assume that you're getting back CD and DC, you're getting back. I want to add B to it. So I want to make it BCD and BDC. That's what I did. I added that prefix plus element. And these two I want to append to all of my current answers. So it gets appended to my current answer over here. And then once I'm done with making all of them the first choice, I'm going to return that current answer. Okay. This is what I'm going to do. How long will I keep continuing this? I'll continue this till if length of current string, if the length of the current string is equal to 1, then there is no generating combinations of this or permutations of this. I'm just going to return current string as is. Very specifically, I'll return a list of current string because that is what is expected over here. I'm going to return a list of that current string. Okay. Is the pseudocode somewhat clear, everybody? Is the pseudocode clear over here? For those of you who understand backtracking, again, now there might be people here who've never done recursion, who've never done backtracking and so on. So in that case, I can't really help you. You'll have to learn backtracking a bit. But for those of you who've done it, okay, cool. I think most of you are getting it. Let me quickly code this. I'll again write it in Python. And if you have time, we'll go through that. Okay. So please briefly again for loop. Yeah, sure, I'll do that. For each element in next, I'll do that. Yeah, okay. Yeah, I'll do that. While I'm coding, I'll show that to you. Okay, while I'm coding, I'll put a over there. I'll do it in Java also. Don't worry. I'll do it in Java also. Okay. But yeah, first to very quickly get it out. So I'll just say n is equal to int input. And for in range n, what am I going to do? I'm going to say, let's say word is equal to input. So this is the word for which I should generate all of the permutations. Okay. Then I will say, let's say answer is equal to generate for this word. That's it. Answer is generate for this word. And this is going to be a list. So I'll print out for I in answer, print I. And the question does say that after I'm done with that, print a new line. So I'm going to print a new line over here. Okay. Let's now focus all our energy on def generate. Let's say the current string. This is the current string. Generate for it. Okay. So we have to arrange them in lexicographic order. Yes, very good. So actually what we will also need to do is we will also need to sort this array first. I'll come to that at the end. Okay. Let me come to that part at the end where I'll sort this array first and then we'll go ahead. Otherwise people will get confused here. Let's go here. So what's going to happen is assume, for example, let's say you have A, B, C, D. Okay. Let's start with this. Assume you have A, B, C, D. Okay. What I want to do is I want to give each element the chance to be the first element, right? The prefix. So I'll say, you know what? Let's say current permutations is equal to this. It's an empty list. I have no permutation so far of this one. Okay. Then I'm going to say, okay, all of them should get a chance. All of them should get a chance to be the first element, right? So I'll say for I in range len of current str, for I in range len of this, what am I going to do? I'm going to say, okay, prefix is equal to current underscore str of. Now you can't do current str of I in Python. You can't extract string elements like that. That is that how it works? No, you can't do this. You'll have to do I plus 1 in this way. So it just gives you the substring. It's just the slice of it, right? So you can't really just do of I like that. Can you? Yeah, you can do I also. Sorry, you can do I also. That's in Java. You can do that. Anyway, so yeah, you can do this over here. So I got that particular element. I also need to remove that element, right? This is an important part. I need to remove that element. So I'll say the remaining is equal to whatever the current str is up till I. This is the slicing that I'm doing up till I plus current underscore str I plus 1 beyond, right? So I don't want that ith element up till I and then beyond I until I plus 1 onwards. I want that. So this is the remaining part. I will then say generate for the remaining part. Okay. And generating from the remaining part will give me what? It will return something back to me, right? So I'll say other permutations. Let's say permutations is equal to this. This generating will return that other permutations back to me. For each of the other permutations, the new permutations that you got, what will I get back here? For example, first here, A will be the starting point. Then B will be the starting point. Then C will be the starting point. Then D will be the starting point, right? So let's say A is the starting point. This one will become B, C, D. That's what this will become. So what I'm saying here is go ahead, generate for B, C, D. What's it going to generate when I say generate for B, C, D? This is actually going to give me a list. How will it give me a list? This is the part I'll get to, but it's going to give me a list of BCD, CBD, no, sorry, BCD, BDC, CBD, CDB, okay, and DBC and DCB. Right? This is what it's going to give me: BCD, BDC, CBD, CDB, DBC, DCB. Right? All right. So it gives me this list. Now to each of these elements, I need to prepend the prefix. I need to prepend the prefix. So how would that be? I'll say for, let's say other in other perms, other permutations. What I need to do is I need to get that other and I need to put it in my current permutations, because these are all the permutations of BCD. That's fine. But I need to prepend A to it. So I say current underscore permutations dot append. What are you going to append? You're going to append prefix plus other. So what's prefix plus other here? It's going to give you ABCD, ABDC, ACBD. Each of these are going to be appended to my current permutations. Once I have done that, I'm going to return the current underscore permutations. Okay. Is other permutations a list? Yes, other permutations is a list. This means the generate function should return a list, which is what I'm doing. Right? It's going to generate a list. This will keep going on until I reach the final element. So I say if len of current str is equal to 1. Let's say it's 1. I'm going to say return current underscore str. That's it. Just that one thing. Okay. All right. Let's see how it goes. 1 second. Did we have any issues? Current star is not defined. Okay, so I must have written star somewhere by mistake. Where have I written current? Yeah, here we go. Current str. Okay, cool. So now we are getting the issue of okay, cool. This is the case we're getting where AABB is not really starting with this one. Okay, this one came correct, this one came correct, but this one is starting with B directly and then it's going to A. Why would that be? Okay. Okay, we can do one very simple thing is we can just sort the answer afterwards. So we can always just say answer.sort, right? And it should ideally work out. No, okay, that is also, okay, it's generating too many. Okay, I got the issue. Okay, this is another issue. This is the BAAB, right? So this is repeated elements. Okay, cool. So what we saw so far, anyway, I'll get to that. But what we saw so far is that we are getting, we took only for unique elements like ABC, ACB, and so on. But what we actually need when we look at something like BAAB, if the element's already there, then you're not going to get a it has to be unique, right? Like AABB, there's no point in generating AABB again, right? So you'll have only the way to look at it is if I look at, yeah, I'll use a set, but just to tell you all, AABB, this is a good aptitude question. How many unique permutations of this exist? Everybody, can anybody tell me for AABB? It's not 4 factorial, it's not 24. What's the number of unique unique elements, unique permutations you're going to get for AABB? Very good. Very, very good. 4 factorial by 2 factorial into 2 factorial, which is equal to 24 divided by 4, which is equal to 6. Right? So you're only going to get 6 unique ones. This is the formula. 4 factorial is the number of elements. For each element that repeats, how many times it's repeating? Factorial of that also. Let's say, for example, it was AAAB, right? So it would be 4 factorial into divided by 3 factorial into 1 factorial, which would actually just be 4. You only get 4 variables here. Okay, cool. What does that mean for us? In our case, all that just means is instead of having like a a list, I guess we will need to maintain a set, right? So it just becomes a set, and current permutations dot add, instead of append, it becomes add, and this other permutations is equal to generate. This is fine. This is fine. This is fine. Return fine. Here we need to return set of this. So we'll just make it a set instead of a list. Hope you all know what a set is. I believe so, right? N is generated, answer is generated. So you cannot sort a set. So answer is equal to list of answer, and then answer dot sort, and then you do for I in answer and so on, right? So now it works out, and if I submit it, it should work out, right? So yeah, this is the other important part. You can't sort a set. There is no indexing in set, so you can't really sort a set. You convert it to a list, sort it, and then you print it. Okay. Okay, somebody asking, before appending the string to the list, check if it is already present in the list. Another approach. Okay, that's a good point. You could do that. The only issue with that is checking that is an order n. So in a list, because a list is not really sorted or anything, it's not using hashing. If somebody is asking that, instead of doing a set, you could have just done append, but before doing append, check if exists in current perms, then only add. The only issue with that is the only issue with that is that checking at every time, if I check in a list, it's an order n approach that will cost you much more than checking for a set. So even if I did this dot add, it's not going to be order n, it's going to be order 1 over here, because set will be much faster in that case. Okay. Clear, everybody? Can I move on to the Java one? Okay. Can I look at the Java one? What's the last test case? It's all working, right? There is no issue in the test cases. BAAB. Yeah. So what about that's what? No, that's exactly for that reason only we did that. For the BAAB we did the what do you say? The permutations. We use sets. We use sets for BAAB only, so that we end up not storing extra permutations or redundant permutations. Okay. You can also just convert it to a set afterwards. Like, I could have not, instead of using a set here, I could have just created a list. After you're done with all that, create a set, and then from that sort it. So that also is possible. You could have done that also. Okay. Let's go to Java. Let's have a very quick look at the Java implementation of this. So Java students still in the house? Any Java students still around? Do you want me to cover it in Java? Okay, cool. So public class. You know what? If I have that, let me just copy the starting part. The only thing I slightly dislike about Java is how verbose the starting part is. Otherwise, everything else is kind of same. So the starting part's just a little bit verbose. That's the only thing that gets to me. But yeah, once you're used to it, you're used to it, right? It's a brilliant language in itself. This is the number of test cases. And okay, so this part we'll start from here. Okay. All right. So string word is equal to. Sir, can we code in any language in our TCS exam? Yes, you can code in any language. Can you change the language between one question to the other? That I do not know. People who've gone to TCS Ion Center will be able to tell. Okay. Scan.next. String word is equal to scan.next. All right. So I got the word, and now I just want to say I could use an array list here. I could use a tree set here. Tree set will automatically keep it sorted. That's the good part. Let's use a tree set here. Okay. So tree set string, let's say answer is equal to new tree set string like this, right? No, not even new tree set string. I'll just say answer is equal to generate for this word, right? Okay. Let me write the method here. Public static tree set string generate string word, and not word, we'll say current string. So this is a current string. Okay. So assume, like, for example, I got ABCD over here. Let's just say, for instance, what do I want to do? I want to give everyone a chance equally to be the starting part. So what am I going to do? I'm going to say, okay, for int I equal to 0, I less than current underscore string dot length, go through the entire string, I plus plus. How do I extract the substring at this point? So here I cannot do current string underscore I. It's not an array. I can't do that. Okay. Instead, what I'll do is string prefix is equal to, I'll get the substring out of it. I'll say current underscore string dot substring I comma I plus 1. So what this is going to do is it's going to give me the value at I. If you're not familiar with the substring thing, all it does is, what this one does is, it, let's say, for example, I have A, B, C, D, and I've given you 0, 1, 2, 3, and I say, you know what, give me substring 2, 3. It says, get me the element at 2 from 2 up till less than 3. So it will only give me 2, 3. Had I put 1, 3, it will say starting at 1 up until less than 3. So it's going to give me BC. But because I put 2, 3, it says starting at 2, but less than 3. Less than 3 means it's only 2. So you'll get C over here. Okay. So yeah, just letting you know about that. Current string dot substring. It's substring, is it? It's not sub str. Okay, thank you. Sometimes I miss up my Java syntaxes. Okay. Anyway, so I got the substring. Can we use caret? You are absolutely welcome to use caret, but it will get converted to a character, and you'll have to again use string to, like, you have to again convert it to a string when you're concatenating. So that's why I prefer to use substring. Okay. I got the prefix. Now what I want to do is I want to say, okay, let's generate the remaining part. So the remaining string remaining is equal to current underscore string dot substring. I want to take only up till I, not including I. So I'll take up till I plus current underscore string dot substring from I plus 1 onwards. So you can, if you do I plus 1, it will automatically take till the n. But just for clarity's sake, this is called code quality. It's always better to, just write it like this. Like this. Okay. So it will anyways by default take till the end. It's not like it's not going to take the end. By default, it's going to take till the end. But still, I just put it there so that you and I are both clear. We all, know it. Okay. I got the prefix. I got the remaining. What am I going to do? I want to generate all of the elements from. So what I'll say? Go ahead, generate for remaining. Right? Go ahead, generate for remaining. For each element that you get in the remaining. So let me say other permutations is equal to this. What is the other permutations? Now, this is not Python where I can go without giving a type. I need to give a type. What is this? I know we are going to return a tree set. Superb, superb. Very nice. You guys are all paying attention. I like it. So tree set string other perms is equal to this. I generate the remaining part. And then I say, you know what? For each string, let's say other in other perms, can we use a string builder? Super, please go ahead. I just didn't do it because there'll be too much of explanation here, but please go ahead and use a string builder. That is much faster, right? Please go ahead and use a string builder, right? So anyway, coming back. So string other, for each string other in other permutations. What am I going to do? I'm going to say, you know what? Go to my current permutation. So I need a current permutations as well. I say tree set string current permutations is equal to new tree set string, right? And then I say, for each string other in other permutations, I'm going to say current underscore permutations dot add prefix plus other, whatever is the other permutation that you got. So you attend that, and then this goes into the current permutations. This will happen over here. Once this for loop is done, I will just return current underscore permutations. right? I'm going to return that. That's a tree set that's going to be returned over here. And for string, yeah, we missed the base case. Thank you so much. So before I go there, let's also get the base case. The base case here would be if current underscore string dot length equal to 1, then you just return we'll have to write 2 lines here, right? You know what we can do, because anyways we need to do this, right? So let's first do that here. And yeah, we anyways need to do that here. And if the length is just 1, I'm going to return. First, I'll add current underscore permutations, not add current underscore string. And then return current underscore permutations. Just return it. Okay. Cool. So that's returned there. If the string is not 1, then we'll go ahead and do the usual stuff and we return that. And then finally for string, let's say X in answer, system.out.println X and new line at the end, right? So I run this, oh, no compiler error also. That was quick. If I submit it, voila, okay, that was cool. I expected some compilation error at least. Okay,